Linear functions. When we're talking about a linear function, we're talking about the form of y equals mx plus b, where m represents your slope and b represents your y-intercept, or it's crossing the y-axis. Now, just a reminder, when you're working with slope, this is the change in y over the change in x. We also know that this formula is y2 minus y1 over x2 minus x1. And also, as we have seen, f of x2 minus f of x1 all over x2 minus x1. Now remember, when you're talking about the y-intercept as an ordered pair, that's 0, comma, b. And so what we want to do is we want to look at some different situations and create some linear functions and see what's going on with them. We know that the slope in a linear function is also known as the rate of change. And so we can also talk about, when you're looking at rate of changes, if it's positive, that means you have an increasing slope. If it's negative, you have a decreasing slope. We can also put our y-intercept in more business terms if you're talking about different items that are happening. It is the y-intercept graphically, but we also call the y-intercept to be the initial value or the starting value, whether you're looking at like the production of something or whatever you may be trying to encounter. So this means this is when your x is equal to 0, and then you can find that other value that goes with it. And so what we're going to do is we're just going to work a couple examples and look at the different ways that we can kind of create some linear functions based off the data that's given to us. So in the first one, it says to start production of a new model of custom wheels, a company will have to produce $30,000, purchase $30,000 in new equipment. Each wheel made costs them $40 in supplies and labor. Write a formula for the total cost TC of producing Q wheels. What will be their total cost in the first year if they expect to sell 240 wheels? And so when we're looking at this example here, what we're going to do is we're going to first kind of create the situation, and then we're going to figure out what's going on from there. So a couple of things that they've outlined here when we're looking at this situation, it says that they want us to find total cost TC. So what they're going to do is they're lining out a new variable, and you're going to see a little bit as you're working through this that we're looking for the total cost function. And so notationally, it's going to be T of C, and then you're going to have parentheses in your Q because it's talking about Q wheels. So they're just kind of lining out those values. So let's start here. It says that $30,000 in new equipment has to be purchased. So the fact of this $30,000 in new equipment being purchased, this is the initial value for this function. It's $30,000 since that's the startup cost. So that means when T of C is at 0, our total cost, we haven't produced anything, that is $30,000. And so if we're looking at that y equals mx plus b situation, that means that we're going to have to take this TC of Q, and we're just going to start with the addition of 30,000 just right off the top. We haven't produced anything. We just know that we're out 30,000 on our costs. Now it also says that each wheel made cost them $40 in supplies and labor. And so this is the next piece that we're going to be working with here. Each wheel made cost them $40 in supplies and labor. So we're going to take that $40 and we're going to multiply it by however many wheels that we produce. And so that means every time we produce a wheel, that's another $40 in the supply and labor of that. And so that's our rate of change. That's our slope. So we're going to have that multiplied by Q, what they want it to represent that wheel. And so for this situation, we're going to have TC of Q equal to 40Q plus 30,000. So TC is an increasing linear function. With this formula, we can take it a step further. So it said, what will be their total cost in the first year if they expect to sell 240 wheels? So now that we have our formula set up, we'll just say TC of 240 would be 40 times 240 plus 30,000. So we'll just calculate that with our on-screen calculator, and that gives me 39,600. So the total cost in the first year of producing 240 wheels would be 39,600. And so this one, just be careful in this situations. It wasn't a lot of computing. Like, I didn't have to find the $40. It gave that to me. Just when I identify where each of those pieces are going. In this situation, since it was represented linearly, that's where I knew I was kind of looking at that y equals mx plus b kind of situation. Now let's go into another one in where we have to find the slope, and I just kind of took it down to the basics so we can walk through all those different processes without the wheels and total costs being involved in that. It says if f of x is a linear function, so the fact that it's saying linear function, that means I should be thinking y equals mx plus b. Then it gives me f of 3 is equal to -2 and f of 8 is equal to 1. Find the equation for the function. So our goal in this situation is just the equation. And so first, let's look at what kind of data was given in this situation. Remember in our f of x, or in our function notation, x is the value in the parentheses. So that means this is an x1 value, and this is the corresponding y1 value. This is the x2 value, and this is the corresponding y2 value. So the first thing I want to do, especially if I'm wanting to land at this value of y equals mx plus b, is I need to first find the slope of the equation. So I'm going to use y2 minus y1 over x2 minus x1, or in this case, since it did use the function notation, we could use f of x2 minus f of x1 all over x2 minus x1. So plugging in those values, I'm looking at, let's see, x2, which is 8, minus x1, which is 3. And then we know f of 8 minus f of 3. So that would be 8 minus 3. F of 8 we know to be 1 minus f of 3, which is -2. Be careful with those two dashes beside each other. 1 minus -2 gives me a +3. 8 minus 3 gives me 5. So that means the slope for my situation is going to be 3 over 5. And then what I need to do is I need to use my y equals mx plus b in order to find the rest of this equation. So this is just my slope or my rate of change. And so for y equals mx plus b, what I'm going to do is I'm going to use that first grouping of information. I'm going to say, well, then that's -2 equal to my m I just found, which is 3/5. My x is 3 plus b, and then I'll be able to find that initial value or that starting intercept there. So let's see, doing some computations here, 3/5 times 3 gives me 9 over 5 plus b. Then I want to subtract that over. Again, you can use your calculator to assist you with this, or I'll just kind of do this by hand and do my common denominator. So that would be a -10 over 5 minus that 9/5. And so then that gives me a -19 over 5. So now that I have my b, I could write this final function. This is y is equal to 3/5 x minus 19 over 5. And so in this section, I didn't want to do a ton of examples. I just want to kind of revisit and remind you of, don't forget, we are looking at situations where y is equal to mx plus b. We're looking at finding our rate of change or slope, and then also interpreting those areas where we're looking for y-intercepts, such in like this case, the production of wheels. Now, although there was only a couple of examples, I'll give you additional resources as you're working through the homework. And then after you've kind of gone through those, if you need additional assistance, please reach out through Canvas messaging.